Okay, so today we're going to be looking at 4.6, the second day, which is formalizing relations and functions. And hopefully at the end of this video, you can say I can use function notation to find the range of a function. So the big question, what is function notation? So here's what function notation looks like. We're going to have an f of x is equal to a negative 4x plus 3. This information right here is giving you the domain, which hopefully we can remember is our x values. So this is simply another way of saying f of x is another way of saying y equals negative 4x plus 3. So it's just a little different notation. Same idea applies. So if I say f of x is equal to negative 4x plus 3, to find the range, we simply plug in the domain that we are given. So where do we plug it into? So the first one, if I want to plug in a negative 1, it would look like this. The function value at a negative 1 is equal to a negative 4 times the negative 1 plus a 3. So this new notation where I have f of negative 1, I'm going to leave over here, which means the function value at a negative 1 is equal to a negative 4 times negative 1, which is a 4 plus 3, which is 7. Okay, then I'm going to do the same thing for the next one. I've got an f function value at a 0 is negative 4 times a 0 plus a 3. So I have a 0 plus 3, so the function value at 0 equals 3. Okay, so if I plug it in a function value at a 1, function value at a 1 would be negative 4 times a 1 plus a 3, which is a negative 1. And also asked to do it for a 2 and a 3. So the function value at 2 is equal to negative 4 times 2 plus a 3, which is going to give me a negative 5. So the function value at a 2 is a negative 5. And the function value at 3 is negative 4 times a 3 plus a 3, which is a negative 9. So the function value at a 3 is equal to a negative 9. So here are the numbers that we are looking for. Function value at negative 1 is 7. Function value at 0 is 3. Function value at 1 is a negative 1. Function value at 2 is a negative 5. And the function value at 3 is a negative 9. Okay, I'm going to shorten this next one just a bit so we can just see what the idea is. I'm going to do for these three in the middle. So the function value at a negative 1 is equal to a negative 1 to the third power plus 1. So I know that the negative 1 to the third power is a negative 1 plus a 1. So the function value at negative 1 is 0. If I put in a positive, or excuse me, a 0, function value at 0 is equal to 0 to the third plus 1. So I get the function value at 0 is equal to a 1. And then the function value at a 1 is equal to the 1 to the third plus 1, which is 1 plus 1, which is 2. So the function value at 1 is equal to a 2. So that's an idea of how we're using function notation, just another way of representing a function. Okay, so why don't you go ahead and try these. Let's just do number 9. We'll forget about number 10 for right now. So if we can just do number 9, so it'd be you try and do it on your own. Pause the video, see what you come up with. So it would be look like this. F of a negative 5 would be a negative 5 minus 6, which is a negative 11. Okay, function value at a negative 3 is equal to negative 3 minus 6, which is a negative 9. Okay, if I plug in a negative 1, it's a negative 1 minus 6, which is a function value at a negative 1, then is a negative 7. The function value at a 1 is equal to 1 minus 6, which tells me that the function value at a 1 is a negative 5. And the last one, a function value at a 3 is equal to 3 minus 6, which means the function value at a 3 is equal to a negative 3. Okay, so hopefully we're able to come up with those numbers. Okay, so a word problem type that you might see, it says a 10th grade class is selling granola bars for a fundraiser. They earn 0.75 or 75 cents for every granola bar they sell. They order 300 granola bars for sale. The function P of B is equal to 0.75B represents the profit the class earns for each bar they sell. Find a reasonable domain and range. So domain would be our inputs, which in this case are our number of bars. Our output is, or our range, excuse me, is our outputs, which is our money raised. So a reasonable input would be anything from 0 to 300 bars because that's all they have to sell. So the reasonable output or the range, if we put in a 0, so their output would be 0. So if I put in a 300, I'd have 0.75 times 300, which is, I believe, 225. Let me grab a calculator quick. 300 times 0.75 is $225. So a reasonable domain would be 0 to 300. A range would be 0 to $225. Okay. Next one, function t of x equals 150x represents the number of words you can speak in x minutes. How many words can you speak in 20 minutes? So 20 is going to go in for the x. So t of 20 is equal to 150 times 20. So in 20 minutes, you can speak 3,000 words. Okay, next one. If f of x is equal to a 40, or excuse me, x squared minus 15, and f of a is equal to 49, what's the value of a? So we want to figure out what the a would have to be, or the x would have to be, in order to get a 49. So the question that we are asking is really this. X squared minus 15 is equal to 49. How are you going to figure out what the x is? So hopefully we can logically think through this and think that we're going to add on 15. And you would get x squared equals 64. So x would have to be a positive 8 or a negative 8. And next one. What is the value of x that makes the relation 3, 5, 2, 5, 9x a function? And that one I'm going to be checking to see if you got that. So that will be our bell work on Monday. Is one of the questions will be this. Can you answer this question? So I was asked to give a shout out to period 4. So hopefully period 4 is listening. And that is a wrap.